So this is a questions or an example on gravitational potential energy. Now, the question is as given. An asteroid with a mass of m is equal to 1.0 to the power of negative 99 kilogram comes from deep space, effectively from infinity, and falls toward Earth. So question A asks you to find the change in potential energy, which is our delta PE, when it reached a point 4.0 to the power of 8 meter from center of the Earth, just beyond the orbital radius of the Earth or the Moon. In addition, you also need to find the work done by the force of gravity. So to solve this one, just apply this equation. Our delta PE is equal to potential energy final minus with the potential energy initial. With the equations of potential energy or gravitational potential energy is equal to this one. Negative G is our gravitational constant times with the mass of the Earth times with the mass of the object, which is in this case is the asteroid itself, divided by the distance of the asteroid to the Earth. So by substituting every information given into this equation, you will get the value of the change in potential energy is equal to negative 9.97 to the power of 14 joule. The value is in negative value. Now, to find the work done, I know that the relation between the work done and potential energy, which you did learn about this, yeah, relations in your chapter 4, the work done by the gravity is also equal to the negative of the change in potential energy. So the work done by the force of gravity in these questions also equal to the same value, which is in positive form, 9.97 to the power of 14 joule. Now that was A, and with the same questions, B asks you to find or calculate the asteroid speed at that point by assuming it was initially at rest when it was arbitrarily far away. So to calculate this one, I just need to apply these relations of kinetic energy and potential energy, which is the conservations of energy. You also did learn this one on our chapter 4. So by substituting the kinetic energy, which is equal to half mv squared, and then minus with our potential energy that we just get on our question A, we will get the value of velocity is equal to 1.41 to the power of 3 milli per second. Now, with the similar questions, question C asks you to find how much work would have to be done on the asteroid by some other agent so that the asteroid will be traveling at only half the speed found in B at the same point. So to calculate this one, I will apply the work energy theorem, which this theorem also did learn in our chapter 4. So the work energy theorem is equal to this one. W is equal to the change of kinetic energy plus with the change of potential energy. Now I need to find the work done when the velocity is half from the velocity that I find in question B. So by substituting everything with the velocity is equal to 7.05 to the power of 2, I will get the value of velocity is equal to negative 7.48 to the power of 14 joule. So that's it for the example of potential energy.